Hi, everyone. Welcome to section 10.1. In this chapter 10, we are going to be discussing counting methods. The first section is counting by a systematic listing. So we're going to be listing items. So the section is called Counting by Systematic Listing. What are the objectives of the section? We are going to be using systematic approach as one part of a counting task. We're going to be using something called a product table to perform a two-part counting task. We're going to be using a tree diagram, and we're going to use systematic listing for a counting task that involves a geometric figure. So we're going to see different types of approach for the same type of counting, which is a listing counting. So the product table, a tree diagram, and a geometric figure. One part task. So the result for simple one-part task can often be listed easily. For the task of tossing a fair coin, for example, for listing the heads with two possibilities, right? So we want to roll a die. We only have two chances, heads or tails. And the task is rolling a single fair die listing with 1, 2, 3, 4, 5, and 6 with six possibilities. So there's six options for you to do a land a one, a two, a three, a four, a five, or a six. Let's look at the first example. When we're selecting a club president, we're going to look at four members. So we look at something called the sample space. So my list of options, my sample space are my options. I have Mike, Adam, Ted, and Helen. I'm going to be abbreviating them as MATH. In how many ways can this group be selected? Well, there's only one way. You can select either Mike, Adam, Ted, or Helen. So there are four options that you can have, each one as a president, because there's only one choice. So there's one choice per person. So then you have one choice, either Mike, so only Mike and there's no one else as president, or Adam and no one else as president, or Ted, no one else as president, or Helen. So those are four choices. So there are four possible results where one of them of the four members as a president. So one time Mike, one time Adam, one time Ted, one time Helen. That's four options. Now, what if you're building numbers from a set of digits? Now it's saying determine the number of two-digit numbers that can be used from the set 2, 4, and 6. Now, again, you have how many options? It consists of two parts. So you're selecting two out of the three. So how many ways? So you can do a 2 and a 4. You can do a 2 and a 6. You could do a 4 and a 6. So choose the first digit and choose the second digit. So you can use something called the product table, where you can have your options, the 2, the 4, the 6, the 2, the 4, the 6. So it'd be 2, 2, 2, 4, 2, 6, 4, 2, 4, 4, 4, 6, 6, 2, 6, 4, 6, 6. So that gives you 3 times 3. That gives you 9 options. So you have, this is called a product table. So in the product table, it tells you how many options or how many ways you can have two digits. So it's 9 results. So let's say that the first digit is 2, the first digit is 4, the first digit. So you have this row, so row and column. So you have 3 options for row, 3 options for columns. So then you create 2 and 2, 2 and 4. So 2 and 2, 2 and 4, 2 and 6. And then 4 and 2, and then 4 and then 2, and then 4 and then 4 and then 4 and then 6. And then the last one right here in the orange, 6 and 2, 6 and 4, 6 and 6. That gives you a total of 9 possible outcomes. So you're selecting 2 digits out of 3. Now we are going to look at the third example where it's saying now you want to roll a pair of dice. Determine the number of different possibilities when 2 ordinary dice are rolled. So now you have 6 options per 1, 2, 3, 4, 5, or 6. So you're going to have a product table that involves 6 horizontal, 6 vertical. So you have one dice and another dice because it's a pair. So you have a pair of dice. And then how many options do you have for the green or the blue? So the color doesn't really matter. This is just an example it could have been a blue die or a red die. What I'm interested in is on how many options will I have. So if I have, let's say the first one landed on a 1, and then the second one landed on a 1, so 1, 1. And then the second time it rolled on a 2. So again, 1, 1, 1, 2. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. That's the product table. Then what happens if you land on a 2? So that's 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. And then 3, and then 4, and then 5, and then 6, and then, well, that's it, up to 6, because I have 6 options. I can only land on a 1, on a 2, on a 3, on a 4, on a 5, or on a 6. So if I add my rows and columns, I have 1, 2, 3, 4, 5, 6, 6 times 6. That will give me 36 options. So I can land on 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, or 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. And we use a product table to determine or to list out all of my options. So we use the technique of a product table to determine the number of outcomes from rolling a pair of die, and it's fair die, because some dice are not fair. So that means your options become much different. So we found a total of 36. So again, 4, 1, 4, 2, 4, 3, 4, 4, and so on. Now, what if we are doing another example? We wish to select 2 club officers. Now, 2 from how many members? So consider a club N with 4 members. So now we have 4 members, and we want to select 2 club officers. So how many options can we have? So now noticing that we have N, a president, and a secretary, or even alternate between. So then we can do this using a product table. So choosing a president and choosing a secretary. So this task, we want to first identify. Hi, everyone. Welcome back to section 10.1. Now we're working on example number 4. In this example, we are trying to do selecting 2 club officers. We're going to consider a club N with 4 members, Mike, Adam, and Ted, and Helen, and abbreviated MATH. Find the number of ways you can elect a president and a secretary. That means you're selecting 2 options from 4 people. So if you're doing 2 options, that means 2 tasks. If it's a 2 task, remember we're going to be doing a product table that consists of Mike, Adam, Ted, and Helen. There, that column here will be for a president. And then on this way, going horizontal, will be the secretary. So that would be Matt, Mike, Adam, Ted, and Helen. So you have another 4 options down here. But note that if you are a president, you cannot be a secretary. So let's try to do our table. M, so that means you're a secretary and a president. MM, MA, MT, MH. Then you can be Adam can be the secretary, and then Mike can be the president, or AA, AT, AH. So Adam and Helen. Now, if the secretary is Ted, Ted and Mike, Ted and Adam, Ted and Ted, Ted and Helen, or Helen and Mike, Helen and Adam, Helen and Ted, or Helen and Helen. Now be careful because when I have duplicates, so MM, AA, TT, and HH, that would mean that Mike is both president and secretary, which is not possible. So you can't be both. Adam cannot be secretary and president at the same time, so you need to remove those options. So those are double counting. Ted and Ted cannot be both secretary or president. And lastly, Helen cannot be both president or secretary. So my options, instead of being 4 times 4 is 16, so it's going to be 16 minus 4 options. That's going to be 12 ways. So there's 12 different ways that I can rearrange. So there it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. From the table, we see that there's 12 possibilities because we had to remove the other 4 since we cannot have repeats. So we cannot be both secretary and president at the same time. So whenever we have a 2-part task, that means we will have to do a product table. Now let's look at this one. Find the number of ways of a club N on the previous slide can appoint committee of 2 members. Now, because you're using a committee of 2 members, that means it's only 2 members. So there's only a committee of 2 members. So for example, we would have to say that MA is the same as AM. So that's 1. MT and MT and TM, that's another one. So those pairs, MH and HM, that's another one. So the different colors. And then if I do blue, TA and AT are the same. And then if we have purple, HT is the same as TH. And then of course, if we do AH is the same as HA. So notice that we are only going to look at appoint a committee of 2 members. So you're exclusively doing MA, MT, MH, AT, AH, and TH. So that cuts it in half. So MA and AM are the same. So then on the previous slide, we noticed that we're only looking at the pairs. The pairs makes no difference. So then MA and AM is the same. MT and TM are the same. So then you're reducing that sample size to 6 possibilities. Now, the third part is to looking at another way of counting is using a tree diagram for multiple parts. So on the first one, it was nice and easy. It was just listing the number of options. Then if there's a 2 task, then we did a product table. And then the third time, now we're looking for a multiple part task. That means that a task has more than 2 ways, so it's not easy. So another device that we're going to use a different type of counting is called a tree diagram. So let's look at that example. So it's asking us to find the number of three-digit numbers that can be found by using the numbers 2, 4, and 6. So the first option, so there's three digits. So you have 2, 4, and 6 for the first option. And then we have another 2, 4, 6, 2, 4, 6, and 2, 4, 6 for each one. So the first digit, the second digit, and then the third digit. So 2, 2, and then 2, 4, 6, and then each one 2, 4, 6, and then 2, 4, 6. So what we're going to do is we are going to create a so-called tree. So for the first option, we have the digits the digits 2, 4, and 6 for the first option. If you already chose a 2, then you only have 4 and 6 remaining. And then same, if you already did 4, then you only have 2 and 6. If you did 6, then it's 2 and 4. So the third option, so it's either 2, 4, 6, or 2, 6, 4, or if you're 4, then you can choose 2 and then 6, or 4 and then 6 and then 2, 6 and then 2 and then 4, 6, 4, or 2. So again, the first option, all of them are available, right? So 2, 4, and 6, that's the first choice. The second choice, the second digit, well, what do you have remaining? 2, 4, 6. So 4 or 6. If you already chose a 4, then you only have a 2 and a 6. And if you already chose a 6, then you have a 2 and a 4. Now the third digit, the only one remaining would be the 6. The only one that's missing is the 4. The only one that's missing is the 6. The only one that's missing is a 2. The one that's missing is a 4. The one that's missing is a 2. So then you make the 2, 4, 6, the 2, 6, 4, the 4, 2, 6, the 4, 6, 2, the 6, 2, 4, the 6, 4, 2. That tells you you have 6 possibilities, which is to choose your digits. So what would be the other systematic listing method? So there are additional systematic ways to produce a complete listing of possible results besides product tables and tree diagrams. The other way is actually using a geometric figure or a polygon. So counting triangles in a figure, how many triangles of any size are in the figure below? So there are actually 12 different triangles, and you can kind of see them from the outside to the inside. So if we have how many options or how many triangles, if I do the first one, the big one, A, D, B, and then I can do from the inner to the outer, I can also do A, F, B, which is this one. But then I also could do A, the smaller one within that one. So that would be half of a piece of A, E, this angle, this part. Let me do another color. So this triangle right here, that piece. So it's the big one, and then the A, E, B. So we have two pieces. So we have A, E, B, that big one. So there's three in this triangle here, there's actually three of these. So you have this A, E, B, which is this one, A, E, B. And then we have A, E, F, so we kind of cut it in half. And then we can have A, C, A, E, C right here. And then within those, we can have C, E, B. And then D, E, C, right? We can have this piece. We can also have CFB, but then also this DEB, which is the bigger one, which is this one. So we have 1, 2, 3, 4, 5, 6, 7, 8. And then we can also have the triangle um, ACB right here. So that's ACB, which is this one. And then again, within those triangles, we can have more. So if we kind of like exploit all of the opportunities, so then we have ADC, right here, ADC is another one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we're missing 2. So then we would have to look at the pieces individually, which are